The deployment of network services is a little bit different in terms of considerations than designing around network services. For deployment, you're going to need to understand the feature sets and configuration options a little bit more. Let's talk about Cloud DNS, Domain Name Service, and we're going to put this in the context of AWS. AWS has a service named Route 53, which performs DNS. And while it can perform a lot of the same things as classic DNS, like public hosted zones, which can be resolved across the internet, it also gives you the option of creating private hosted zones. These can be resolved within specific VPC networks. AWS takes it a step further and allows you to create private hosted zones, which can also be resolved from on-prem networks using forwarders and endpoints. Now, this does require private network connectivity, possibly through VPN. Next, we have NTP, Network Time Protocol. This is where you get your time synchronization for all your various OS-based servers. Active Directory for Microsoft does this automatically, so there's no need for extra configuration. For Linux, there's a lot of configurability in terms of which servers you would like to use. But the time can also be delivered from the host operating system or hypervisor if you're running a virtual machine. DHCP, Dynamic Host Configuration Protocol, is a really important service to have set up correctly. This is what allows your virtual machines to receive their network configuration dynamically so that you don't have to statically define it. And this could include host names, the fully qualified DNS domain name. It could be private IP addresses, subnet masks, default gateways, DNS servers, and NTP servers, so that you don't have to configure any of this in the operating system. It's simply provided as a service when the instance starts up. Another really important service is called IPAM, IP Address Management. And this is a process or a service which makes sure that as you create virtual networks and isolate them using segmentation, that you don't end up with network address conflicts because of overlapping ranges. In this particular diagram, IPAM would help you avoid the situation where you create two VPCs with identical network ranges. But it could also be used to help prevent partial overlaps where one network is a subset of another. Finally, we have CDN, which stands for Content Delivery as a Network. And this is how you cache web assets or multimedia assets closer to your end users. The purpose of this is to not only reduce the load on the back end, but it also improves the overall performance in terms of lower latency and higher throughput. An example of how this works is AWS CloudFront. And let's say that a user makes an HTTP or HTTPS request for an asset. CloudFront is going to identify which of the various data centers that operate as edge locations are closest to that end user. If that edge location has the asset already cached, it's simply served back to the client. But if it doesn't, then it's going to reach further and test what they call the regional edge caches to see if the asset is there instead. And only if it is not available in any of those two layers of caches does it finally reach out to the content origin to pull that asset and then cache it at both layers while serving it back to the end user.